Hi, my name is Calvin, and I'm going to be taking you through my Comp 2152 Assignment 2. So Assignment 2 comes in two parts, Part A and Part B. Part A is a math game, which has two random numbers generated by the program and a random operator, and then asks the user what is the result of the random number 1, operator, random number 2. So for example, the program can choose 7, 8, and a plus. Then it'll ask what is the result of 7 plus 8. If the user answers correctly, it'll show a congratulations and add 1 to the user's score. Otherwise, it'll show the correct answer and subtract 1 from the user's score. The program will then ask the user if they want to continue, where if they hit Y, the program will continue, and anything else will exit the program. So let's get to the code down below. First, we will need to import the random library and import our Google Drive. And then this other import is importing the math library. However, that is used for part B, so I will talk about that when it gets there. We will run those import libraries, and then we will mount to our Google Drive. And so we'll run that. As you can see, I'm already mounted, so it will fail. However, if this is your first time running the program, you will need to run that. Then we will check if a score.txt file is already created. That's where we will store the user's score, so that we will know if they have previously played and what their score is. So what we'll do is we'll have a try statement which tries to open and read the score.txt file. If it does open it, it'll say that it is happy to greet the user and whatever their last score was. However, if the file is not found, it'll raise an error saying that no file is found, but it will create one for you. And then if it can't read, it'll say the file is found, however, there's an error reading the file, else we'll have an unexpected error. In this case, we'll run it. You can see it is happy to meet me again. My last score was 1. Then we will define our max score variable set to 0, because when the user runs it, it needs to be 0, because how can they have a score without running the program first? Then we will have the function for our program. So basically, we have a function, myMathTest, with that max score variable, which is now 0. And then we have A, which we have set to a random integer between 1 and 10, B, which is set to a random integer between 1 and 10, and our operator, which is between 1 and 3. If the operator equals 1, we're going to set that to the plus symbol. If it's 2, it'll be minus, and if it's 3, multiplication. So we'll go through if it's 1 just for this example. Basically, if the operator generated is 1, it'll ask the user what is A plus, because it's 1, B, and it just asks what's the result. And then the program will calculate the answer, compare if the user input is the answer, and if it is, it'll display a message saying the user is correct and add 1 to their score. Else, it'll show what the correct answer is and try another question while taking 1 away from their score. And then same thing for if the operator generated is 2 or 3. If it's 2, the equation becomes subtraction. If it's 3, the equation becomes multiplication. So we'll just run that. And then we will scroll down. This is pretty much the entire runtime of the program right here in this one. We have an infinite loop with the while true. We call our myMathTest function that we just went over and defined up there. And then we check if the score is equal to 150, which is the max score, we're going to tell the user, thank you for playing. You got 150, which is the max score, and we will exit the program. Otherwise, we will ask the user if they want to continue after every question. And if they hit Y, it doesn't matter if it's lowercase or uppercase, it'll continue. Otherwise, the program will thank the user for playing, show the user their score, and then exit. For example, what is 7 minus 6? We will say 1, congratulations, we want to continue. What is 10 minus 1? We're going to say 9, congratulations, we want to continue again. So right now our score is 2. What is 4 times 9? We're going to say 5. Now we know it's wrong. We'll say no, we don't want to continue. It's going to say thank you for playing. We got 1 because we got those two questions correct, and then that 1 incorrect. And then we have this to save the file in score, to save the max score, which is 1 that we just got, into the score.txt file. So we will run that, and we can open up our file right here. Mine is just in my comp2152 folder. As you can see, score.txt. We will open that up right here, and it has 1, the variable that the user just got. It will change to whatever score the user gets, and that's how it will remember it for next time. Now on to part B. Part B is about solving a quadratic equation. So first, we are going to welcome the user to the quadratic equation game, and we are going to show them what a basic simple quadratic equation looks like. As you can see here is ax squared plus bx plus c equals 0. And now we will ask the user to input numbers for a, b, and c respectively. For this example, we will set a as 1, b we will set equal to 5, and c we will set equal to 6. Next, we will show the sample quadratic equation with the given variables that they enter. As you can see, a is now 1, b is now 5, and c is now 6. Then we will have a function called discriminant, which receives all those variables that the user just made and create the discriminant that we need for the quadratic formula. We'll run that. It actually does not print anything, but like the other function we defined, all you need to do is run it and it will be good to go. And now this is the main section of the program. As you can see, we call our discriminant function that we just defined right up here. And then we check. If the discriminant, which is this that we get, is greater than 0, then we're going to have 2 real solutions. Solution 1 will be the quadratic formula with the plus, and solution 2 will be the quadratic formula with the minus right here. And then we will output the 2 real solutions with the answers. As you can see right here, remembering that a is 1, b is 5, and c is 6, that will give us 2 real solutions. Now, we can test it with 1 real solution. We can keep a as 1, we will change b to 14, and c we will set to 49. And now we will run our discriminant function again. We can run this sample quadratic equation that just shows you that we updated the numbers. And then we'll run our main again, pretty much, which will tell you that we only have 1 real solution because d is equal to 0 right here. So it doesn't matter which formula you use. You can use the plus or the minus right here. It'll get you the same result, which is in this case, -7. And now, if the discriminant is negative, it'll just say we got a pair of complex solutions. So for this case, we'll just make b 0, a 4, and c 4 as well. We can run this, which shows the sample quadratic equation now. You can see a is 4, b is 0, c is 4. We'll run our discriminant function to calculate our discriminant. And now we'll run our main little program right here, which will check, yep, d is actually less than 0. So it'll output that the discriminant is negative, and we got a pair of complex solutions, which in this program we will not be solving. Finally, we will write the quadratic equation to a text file, and then we will save whatever the output is. So if it's greater than 0, we'll show 2 solutions, what the solutions were. If it equals to 0, the 1 solution. And in this case, the discriminant is negative still because we have not changed it. So we'll just get a pair of complex solutions. So we will run this. It will write into the text file or create one if it is not created. And then it'll say what the quadratic equation is. This is just to put that on a new line. And the output, which in this case is right here, the discriminant is negative. And we can open up that file. As you can see, quad equation.txt. We'll open up, and right now you can see what our sample quadratic equation is. It's the same one from up here that we ran, and our output the same from right here. Thank you for watching, and that was my assignment 2.